Yeah, one of the things that I think would be good to explain about GitHub Actions that would maybe simplify things is just the concept of testing in a modern company. And in particular, the way that people are testing is they're using a combination of two topics. The first one is continuous integration. So with continuous integration, that's where we would go through and do the same steps that Alfredo was talking about and basically automatically test your code using some kind of a build system. And that's really the point of continuous integration, is that you test your code automatically, you lint your code automatically. I guess this is the other part about it, is it's automatic, and then also it's repeatable. So you can bring this particular piece of code in another environment and it will run. So that's really the core reasons for doing continuous integration. And then the question is, well, where are you going to do that? And there are a few options in order to do continuous integration. In the old days, there was really maybe mostly one game in town, and that was Jenkins. And Jenkins is pretty interesting because it's still a good choice for building and testing code. And so it's open source. That's one nice thing about it. It's also based in a Java file format, so you can just download a Java file and it runs, which is great. But the downside of Jenkins is the complexity. And what happens with a Jenkins setup is that you can do a lot of customization. So if you have Jenkins experts in your company, you can build really sophisticated things. On the flip side, though, this may be something you don't really want to tackle. So the alternative, and we'll put this down here, would be third-party build systems. And this is really becoming a trend here, that many people are headed towards using these third-party systems. And a good example of that is GitHub Actions. So that's one way to think about Jenkins and GitHub Actions, is they're competing products. And in the case of Jenkins, even though it does all this great stuff, if it goes down, you have to be responsible for it. But with GitHub Actions, it's hosted inside of GitHub, and there's a deep integration. Another example of this would be Circle CI, would be another example of a vendor inside of this space. So yeah, I guess really that's the main takeaway, is that it's a SaaS-based solution that will allow you to do similar things that you would do with a build server like Jenkins or TeamCity or one of these other servers. And let's now talk a little bit into the details of GitHub Actions, and I'll also talk about what are the features of it. One of the neat things about a hosted service like GitHub, and let's just kind of dive into GitHub a little bit here, is that we know that it's going to have a feature path that's constantly improving. So features, and we'll just say up. And we know that it's improving constantly because it's owned by a major corporation. So Microsoft, which actually has a pretty good reputation, didn't used to have a good reputation for open source, but now has a great reputation for open source. They're constantly releasing new features. They also have the ability to do collaboration. So with GitHub already, people around the world are collaborating with GitHub. And then also there's security scanning, so you can get security features inside with GitHub Actions. And then this is where the build stuff comes in, is that the build component is a YAML based config. And the YAML format, there's pros and cons to it, but the nice thing about it is that it's human readable. So you can look at this YAML format and pretty easily, build out a, steps in a build process. So that's kind of in a nutshell the lay of the land with GitHub and GitHub Actions. And so let's just dive right into it, and let's build out some things with GitHub Actions and show what it can do. So the first thing for GitHub Actions would be, we could go through here and create a repo, and we could call this GitHub Actions demo, and put inside, this is a repo for building out GitHub action and tricks. And what I would typically do when I start this is add a README file so that I can explain what the project is doing, add a gitignore file. We'll cover Python, so I'll type in the word Python, and what this will do is ignore a bunch of files that really you don't want to check in, and then I can say create repository. There we go. Perfect. So now that I've got this set up here, the next thing that I can do is check it out in some environment, and I think a good environment potentially would be Amazon. So I can go through here and I can check this in. I can spin this up, and I'll just use my two-factor auth here and log in. We could use another environment. We could use Azure. We could use Google Cloud. Doesn't really matter. But I like to use this service called Cloud9. And with Cloud9, it's a JavaScript-based development environment. And it's pretty neat because it's pretty easy to use. So we'll again call this GitHub Actions demo. And this is my environment for doing GitHub Actions work. All right. And by default here, I think if you're a new user to Amazon, you can just leave everything default, and it'll use a free tier eligible instance. So it'll grab a really tiny instance for you, which is all you need, which is great about doing development in the cloud. And all the heavy lifting actually is done by GitHub Actions. So all of the building and all this stuff, when we hook it up, will work with GitHub Actions. So the other thing that I'll need to do when I first talk to a project from GitHub in a new environment is set up SSH keys. So I can just go get that ready. If I go to my profile and go to settings here, I can go to SSH and GPG keys and create a new key, and we'll call this as well GitHub Actions demo. There we go. And then once this spins up, and this should take just a second, I'll generate the SSH keys, and then I'll paste those keys into that environment. Yeah, usually this process only takes, let's say, 60 seconds to 90 seconds. There you go. It's ready to go. Okay, now that I've got this set up here, I can go forward with creating SSH keys. So I'll type in SSH keygen-t RSA, and there we go. And I'll go and look for this public file, which will be the public key. And I run the command cat, which will print out the contents of the public key. And then I'll copy from SSH RSA down. And then I'll go back to SSH key and paste this in. It'll ask for my password. Once it asks for the password, we're ready to go. I can start developing against that repository. So I'll pull up this repo as well so that I can share it out. Okay, so now that we've got this thing hooked up here, what I can do next is check out the repo. So I'll go to this icon here, code, and copy this and do a git clone. There we go. All right, so we're all set up here, and now I can get to work and start building things out. there's lots of different techniques that people use when they first create a Python project and get it ready. I like to create a virtual environment myself. I think it solves a lot of problems in terms of isolating things. And so we know that this environment here is running Python 3.6 by default. Although I thought it ran Python 3.8 as well. Let's double check. No, it doesn't. Okay, but basically it's running Python 3.6, and I'll type in Python 3-m-v-e-n-v, and this will let me create a virtual environment. I like to name it the same thing as the repo so I don't get confused. So I'll go ahead and do that. I'll say tilde slash dot GitHub actions demo. And I do this so that it hides it into my home directory as an invisible file so I don't accidentally check it in. And then I can source it, go through here, source, tilde slash dot GitHub actions demo bin activate. There you go. And in fact, if I want to be extra slick here, what I can do is I can go to my repo here, README, and I could give some instructions to somebody, to use my project, you can do this. And then I could put in some quotes here and just tell them, create a virtual environment and then source it, right? Which is kind of nice, so that I'm telling people exactly how to use my project. All right, so that looks like it's good to go. I can save that, and if I source it, I now have my virtual environment set up, and I can say which Python, and you can see that it's using the Python in that directory that's in my home directory. Now I would start to scaffold this thing out as well. So I would build out a README file. Build out a requirements file. So go through here, requirements.txt. And this is where I would put the packages so that if I wanted to have GitHub Actions do things, this is where I would put the list of steps. And from here, the packages that I typically use would be, I like this Python Black tool, which is a formatting tool. I like PyLint. I also like PyTest, and I also like PyTest Cov. So these are probably the tools that I would recommend using in your project. You could substitute PyLint for PyFlake. Some people like that better. But in general, this is my opinionated recommendation for building something. And also, I use the command line tool library Click so much. Sure, let's also put that in there because I like to build command line tools. Okay, so I got this set up here. And now how would I install these packages? What's a good pattern? Well, I would recommend using a Makefile, because a Makefile is on basically every system that's a Linux, Unix-based system. And it's easy to put annoying commands as a subcommand in a Makefile. So if I go through here and I say Makefile, I'm going to go to a Makefile that I've got hooked up somewhere else and just copy some of it. So I think I have an example in my GitHub repo of, let's say, something from PyTest, and I can just grab some other. Here we go. Here's probably a good one. I can look at a Makefile that I created earlier and just basically paste it in to this project, which I think is not a bad approach. Is once you set it up once, why reinvent the wheel? So let's look through and see what these steps are. So the first thing is that I have a step called install, and I put pip install -- upgrade pip. So this upgrades the Python packaging tool, which always happens to be out of date for some reason. So I figure let's just upgrade it automatically. And then I also install the packages inside of here. So in my opinion, this dramatically simplifies the way that you do software installations, because now on the GitHub Actions build server, when we set that up in a second, I can just type in make install. I don't have to paste all this in. Likewise here, this is a format step, and this will use that formatting tool to make my Python code look better and it will format that code. And this is a lint step, and this lint step will check my code for errors. So if I wanted to build out a hello file, which we will do in a second, it'll go through and lint it. And notice that I disable the recommended and configuration warnings, which in my opinion are just basically not useful at all. So I just disable them. I only want to see the warnings and the errors. So like if the code literally won't run because there's a syntax error. And then I will also test my code in this step. So I think this is one thing that I do see a lot with newcomers to Python, is that they aren't using a Makefile. And then when I explain the Makefile, there's a little bit of pushback, like, hey, well, why are you using a Makefile? This is more work. And my pushback to them is that, in fact, I've been around for a while and I'm actually lazy. I don't want to work that hard anymore. This is working hard, is putting all these commands in. It's too much work. Instead, if I paste them into a Makefile, I don't have to remember anything anymore. All I do is I type in make install, make format, make lint, make test, and it's just easier to use those tools to install my code. So what I'm going to do is I'm going to do this step here first. I'm going to type in make install. And again, in my opinion, this is much simpler. I don't have to remember one command at all, and it will install my code. And in this case, for some reason, this, and it's kind of nice, it showed me that there's a problem, that this Python black tool it blew up. So, these kind of bleeding edge tools, that happens all the time with it, not a big deal. What I will do is, and look, it even said Python black 20 bot. So there's a couple different ways I could try to fix this. I could actually go to the Python packaging repo, packaging, and probably the bleeding edge people, we could go to PyPy. They probably have given me too new of a version of Python. And so I would need to either backport this and fix it, or just ignore it, which I'm probably leaning towards ignoring this PyPy. But we'll see here in a second. Okay, and if I type in black, we could probably go back in history here and find maybe, oh, I guess it's still kind of a beta product. So yeah, maybe what I do is just say, look, this is too cutting edge. I'm going to take this one out. And what's nice is I got to see this really quickly by having this simplified install step. So what I'll do is I'll just take this out, and I'll also go to my Makefile and say, I don't need this formatting tool. When you fix your code, I'll install it again, and then I can just say make install. There we go. And then now this will get past that step, and it'll install, in theory, PyLint. Yeah, there's some other. I think it's because I had probably that tool created some kind of a conflict. So there's a couple ways that I could solve that. One is that I could uninstall the package. So we can say uninstall pip, which I have to look up. I do it so infrequently. So we can say pip install -u. So I think you can just do pip install -u. Yeah, so I can just do this and then say black, and let's see if that fixes this. All right. So basically, that beta tool totally screwed up my environment. Which there's a couple. I'll show you an easy fix for this. Would be this, is that I can just deactivate this environment, and then I can essentially just nuke that repo that it created here, which is, if I type in history, I can just do this. I can just say rm-rf, goodbye, and then just do it again. Just create the environment again and say, create my new virtual environment, and then source it. And then just do source history and source this up again. There we go. And now do make install. And let's hopefully nothing blows up. Well, so we have a second problem tool, which it looks like for some reason maybe it's PyLint is actually having an issue as well. So I guess this version of Python is got some issues. So let's do it again. Let's keep fixing it. So this is kind of actually an accidentally fun thing to fix. So again, I'll deactivate, and let's just keep taking tools out that are causing problems. So again, I'll nuke that. Now I'll take out PyLint, and we can go through here and we can just again create the virtual environment, again source it, and then do make install. So I think this also shows even when you get into weird issues. So it wasn't that tool. So I wonder which tool it is that's blowing up here. So we can see if I can test. Maybe it's Click. Let's keep maybe at this point I can actually go through here and see if I try it myself. If I say pip install Click, is that the one that blows up? No, that works. Pip install pytest-cov, does that work? Oh, it's pytest-cov. There we go. So I think the other thing about this that's pretty neat is that you can actually quickly debug which package has got a problem using this approach. So I again would probably nuke my environment just to be safe. I'll just deactivate, and then I'll again create a new virtual environment, and I will say source it, and now I'll do make install. So we're only going to install 3 packages. Wow, this for some reason this is we've got a double whammy here, in that it must be Python 3.6 is the issue that we're having all kinds of sudden problems. Yeah, not sure why this is totally messed up. Well, I think what I can do, in fact, is abandon ship on this environment, which just for fun, we'll do this, is I will deactivate everything. I'm assuming this is a Python 3.6 problem. And what I can do is actually just check in this code. So I'll go here and I'll cd into, we'll move these files into GitHub Actions. So it wasn't even in the right directory anyway. So move this inside of GitHub Actions, move this requirements in there as well. And then I will just check this in. So I'll go to GitHub Actions, and we'll say git add, and adding new code. And I'm going to switch to a different cloud provider that has a newer version of Python, because it looks like there are some issues with Python 3.6 that maybe just suddenly cropped up. There must be like a common library that is, and this happens every once in a while. Like you'll be using Python, and then the world changes because there's a new version, and then your cloud vendor doesn't support it, or your local environment doesn't support it. But it's pretty easy to fix. Just for speed here, is I could install a new version of Python. There's a lot of things I could do, but I'll just switch gears to use the Google Cloud. So I'll go through here and I'll say git push. Okay, so I push this code in, and we have some code in here that looks good. And in fact, what's pretty funny actually is, just so I can make very quick progress, before I use Google Cloud, I'll show you that you could even start using GitHub Actions right now. So one of the things that we have here is PyTest and click, and I could actually double check GitHub Actions and see, does it work with, let's say, Python 3.8 or Python 3.7. So I can go to setup workflow here, and then inside you'll see that it creates this essentially like a hello world based series of steps. Well, what I can do is go back to one of my other projects that has GitHub Actions set up and just copy it up. And in fact, I can debug things before I even get to a new cloud provider. I can just go like this and then go to GitHub Actions and paste this in. And in fact, I'll just take out the steps for now that I actually only care about testing my installation. And I could actually test this with Python 3. Let's do Python 3.7, because that's, I think, what's on Google Cloud. So let's do Python 3.7 and just say, hey, I want to just see, does anything work with Python 3.7? And I could say testing installation with Python 3.7. And if I go in there, now this will spin up a new environment, and then it'll actually test my installation. So I can actually debug my other environment here by using this tool, because if you remember, this environment was running Python 3.6, right? And that was Python 3.6.12. And so maybe I think there's a problem with Python 3.6. Do these installs work? And let's see. So they do work, right, with Python 3.7. So I could even, if I want to try something really tricky, I could even see if I could put in this version of Python and see if it blows up. So if I could go back here and go to GitHub Actions, I could change it and see, can I replicate that problem directly to Python 3.6.12? And let's see if I put that in and I say Python 3.6.12, does this not work? And let's see. Okay, we'll commit the change and then go to Actions. And it's possible there's something specific about the AWS environment, but it would be great if this doesn't work. And then I can replicate and say, uh-oh, there's something with Python 3.6.12 that's a problem. We're about to find out. And well, that's weird. So maybe there's something in particular that's just weird about that version of Python on AWS, which is kind of interesting. But inside of here, though, I'll just change this again to Python 3.7. And in fact, I can double check. So let's go to the Google Cloud now, and I'll go to GCP Cloud and try this out and check this code out. And if I click on Activate Cloud Shell, I can now have a brand new cloud, brand new environment, and just see, are things as messed up here? So if I type in Python 3, we can see that's Python 3.7.3. Okay, so that looks good. Let's see, in fact, if I can just change this in GitHub Actions, and even before I even start writing code in that new environment, do things get better? 3.7.3. Okay, so let's test out our new environment and check it out. Again, we'll go to Actions. So this is actually potentially one of the cool things about GitHub Actions is I can actually use GitHub as a way to debug what's going on and say, hey, what is happening in my local environment? And then actually essentially see what does work, which is, well, here we go. Here's kind of interesting is that in particular, this one is not available. So they're making it fun for me, is that the only versions that are available on GitHub Actions are 3.7.9, which is probably good enough. So we let's go through and we'll change the GitHub Actions here to be 3.7.9. And we'll go here and we'll say 3.7.9. Go here, 3.7.9. That's probably close enough. Okay, do it again. Yeah, so you can almost think of this as another development environment. It's just a web browser where I'm testing my code and debugging things. And let's see, does Python 3.7.9 work? Okay, we're getting somewhere. All right, we have something working. And since I'm here, I'll show you one of the things you can do with GitHub Actions as well. Is if I go to this top section here, there's a hamburger menu. I can say create status badge, and I also can paste this into the markdown, which is not bad. It just shows you whether the project actually works. So let's go through here and let's do that. And I'll go and paste this in. And here we go, paste this in. Perfect. All right, so we got this thing working. Now let's see if we can be successful and get it actually doing anything useful on another cloud provider, just so I can keep making forward progress. Okay, so I'm gonna do the same thing here. Is I'm going to git clone like this, and on the Google Cloud, when you create a virtual environment, they make you do it with virtual env, which is similar to the way I did it before, but I'll do the same thing. I'll just say tilde/dot GitHub Actions demo. So go ahead and create this virtual environment and then source it. GitHub Actions demo, bin activate. And now do the make install, right? So if I go cd into the GitHub Actions demo repo, if I see here, we've got that make file, I can type in make install. Fingers crossed, do things blow up here? And they actually work. Okay, so we successfully used GitHub Actions to actually switch to a different cloud provider while we isolate that other issue. So I can now go back and even gently add those other tools in to see if they work. So I could, in fact, open up this editor that they've got if I don't want to use a command line, and I could go through here and just add a couple installs to the requirements step by step to see if I can get things installed that I had before that I wanted to. So here we go, GitHub Actions demo. I'm going to go to this Makefile. We've got that. Lint, that looks good. Let's go through and let's see if we can get pylint working. So let's try that first. So I'll say pylint, go back to the terminal and say make install. Does that work? Should I make install? Let's see. Okay, that's good. And let's go back now and let's add in the Python black tool. Does that work? Again, I'll just save this. Okay, make install. Okay, well that worked. And then what about that PyTest cov library, which also seemed like it has some kind of an issue? Does that work? Go back here. Great. So all these look like they work. And so in fact, what I'll do is also verify this with GitHub Actions. So I'll do git status and add in this requirements file, adding 3 new packages that work on Python 3.7.3. Okay, and let's go ahead and push this change. And now I can go back again to GitHub Actions, and we should be able to see this thing building. And we can go to Actions, look at the build, and in fact verify that this will install over here as well. Okay, it looks like it works, so great. So there was definitely something weird going on that AWS environment that I could, in fact, I might even try to debug that in the second hour to show you how we could do this. But basically we got this thing working, and now I can do what I was attempting to do before, which is start to scaffold things out a little bit locally. So I'm going to go to an editor here, and what I would do next in setting up more of a comprehensive GitHub Actions project is to create a hello file. So I can say file, new file, and we'll call this hello.py, and just put something simple like I like to do an add, because it's one of the simplest things you could build, X and Y, and put some documentation here like this is an add function, and also return back X plus Y, right? So it just returns back a sum, and I could just print 1 and 1 is 2, right? Okay, so I'll go ahead and do that. If I go back to the terminal, I can just run it to make sure it works. Make hello, not make hello, Python hello. Okay, actually, I screwed that up. It's 1 prints add 1 and 1. There you go. And go back to terminal and run this. Perfect. So we get 1 and 1 is 2. So I could now actually, if we look back at this file, this make file, if you remember, I had this lint command, so we can actually use this now. So I'm going to go ahead and say make lint. So we'll go through here and say make lint, and we know that the code works. I can also verify that it would blow up if I changed it. So if I broke it and just said, I don't know, like just change into a function that doesn't exist, I could go back here and say make lint, and it'll blow up, and it'll tell me, uh-oh, you have an undefined variable add 3, right? So that's the whole point of the linting process, is you don't even need to write a unit test, and it will tell you your code is broken and check it, which in my opinion is a no-brainer to add to any project. Is why would you not want to know that your code it doesn't work? I've actually had people tell me, even my manager at one point in my career told me, yeah, this isn't that big of a deal, it's okay to check in code that doesn't work. I violently disagree with him. So you should never check in code that doesn't work, and that's the whole point of linting here. So I'll go ahead and fix this. And the other thing I'll add is in the requirements file. Remember, we have the black tool. So I'll go ahead and add that format step back again. So I'll say format, and then I'll do black asterisk.py. So basically anything that you can find, just reformat it. And notice here that this is, I think, probably not compliant with the Python standard for PEP. Like I probably have spaces wrong or something like this. That's what this tool does. So if I go back to the terminal, it'll clean it up. So we'll go ahead and we'll say make format. There we go. So it did reformat it. What did it do? You can see, look, it kind of cleaned it up a little bit, made it look a little bit visually more appealing. So I think it's not a bad tool to have this in your setup here. So now that I've got some more stuff, The other thing that I could set up is just a really simple unit test. So I'll just add a unit test for this. So I'll say touch test hello. And then I can again open my editor, go to this, and say from hello import add, and then add in a function that tests this. So test add, and then with PyTest it's really easy, as Alfredo mentioned, is that you can add in just an assert statement, assert, and say that 2 is equal to add 1 and 1. So if I add 1 and 1 together, it should equal 2. And to test it, I just would go again to this Makefile and look at the test. It says run it and include test coverage. That's what this -cov command does. And then do a unit test. So go through here and I'll type in make test. There you go. So it shows that I have 100% test coverage. Everything works. If I want to break it intentionally, I could also just verify that the test works by putting the wrong thing in. So 1 and 2 would be 3. So let's go through here and verify that that does not work. There we go. We've got some great test coverage here. So in fact, just for fun, I'm going to check in this broken code on purpose so that we can exercise the GitHub Actions build server. So we'll go through here and we'll say git status, git add makefile, and then add these 2 files. There we go. And I'll say commit adding a broken test. And you'll see here how valuable it is to have this little gatekeeper, GitHub Actions, constantly being vigilant, watching over my code village and protecting it when something bad happens. And here we go. The adding a broken test, and the broken test here is set up a job, run actions, set up Python 379, install dependencies. So the first thing it does is installs the dependencies, and then the next thing is that I will need to change this because it's not doing linting or testing. So in order to do that, there's a couple ways I can do it. Let's just do it from Google Cloud first, is that I need to go back to my GitHub Actions demo file and find that invisible file. So I think I can go here. I need to tell it to look for invisible files, which is under, let's see, view. Where is this? Toggle render. Yeah, there's the workspace settings, open preferences. There, I have to tell this thing to show invisible files. But if I can't figure it out, it's not that big of a deal. I will just do it from the terminal. Yeah, which is a little bit irritating. These cloud editors are changing constantly, and you never know what new feature they're going to add. So I will just look inside of here and I can see it, right? If I just say LA, I can see that it's inside of this GitHub directory. So I can just do vim and so .github, and then I can say workflows and just change it from here. And notice that these are the steps, right, that I have currently in my project. So I could just say 3YY, paste this, and then do it again, paste this, and just add some steps. So I say make install, that looks good. Now let's add a lint step, and I just say make lints. And then I could also do install dependencies, change that, and say make format. Format. So we'll say make format. And then the final thing I could do as well is add a unit test. So I can say here, and then I can add testing. And probably actually, the order I would probably do would be installation first, then I would do linting, then I would do testing. So I'm going to change this. I would add the test next, make test, and then the last thing would be format. And the reason why is that if the code formatting is a problem, that's probably the last thing you would care about, and it will just show you that there's an issue. But I would probably first want to be made aware that the installation was messed up. Then I would probably want to know if the syntax was messed up. Then I would want to know if there was some kind of logical error in my code with like a unit test. And then finally I would say, hey, look, does the code even format, right? And we can do that, right? There we go, make format. So there we go. I can say get status and just add this and then commit it, adding new steps. All right, so we go back to GitHub Actions here, and there should be a new build, and we can get this thing working. All right, so now it's doing these new steps. It's installing the dependencies. It's going to lint the code. It's going to test the code, and it's going to format the code. So installation appears to be going successfully. Great. We intentionally, if you remember, put a broken test in there. So that's good. It failed. And notice that it won't get to the final step. So this actually is why I would like to first fail at the test section, because I don't want it to fail at format and then I don't know why it failed. The installation and the testing and the linting are all things that are much more informative in terms of telling me what's wrong. And in fact, it exactly tells me. So I could even just fix it in here. I could be very efficient and go to the test file and look as well, which is kind of neat, is that it tells me, things are problematic. So if I go to the test file, I can go in and do this and say commit changes. And from here, I can say update test hello. Go through it again. So we've got installation dependencies. Next up, it installs a lint. Great. The test now passes. The formatting now passes. And it looks like I might have forgot to put the lint step in here or something. So I'm going to go back here and just fix this as well, just inside of GitHub Actions. Did I not put a lint? Make lint. Oh, I called it install lint. So see, that's a good point of, it's important to name your build step properly so that I know what's happening. If I say the wrong name, it will confuse me. So in this case, in fact, the lint step will be fixed, and then I will run it again, and we should have a full working series of actions. So there we go, update, and I can look at it again. So hopefully this shows the power of PyLint and the fact that I didn't have to set up a bunch of complicated stuff, and it actually helped me solve a real problem. And now I've got actually a good scaffold. And in fact, I have enough confidence that I know what's going on that I could isolate this issue to that AWS environment. So I think actually that's probably not a bad thing to do when we come back, is to see, can we fix that environment using the fact that we have a known good build, right? We have a lint test format installed. We know all these work in GitHub Actions, and we know they work here. So we should be able to isolate and figure out what that problem was in that other environment. And then if I want to keep the environments in sync, I would just say git pull, and it would just pull in those changes. And we'll go to the screen share, and I'll go to Azure now and see if we can also kind of debug some of the things that happen in a traditional environment, like a new cloud environment, and see if we can replicate some of those previous issues that we had. So Azure also has a Cloud Shell, just like AWS and Google. And one of the things that's interesting about these cloud environments is that a lot of times they are running older versions of Python, and this is actually why the continuous integration is so helpful, is I can test and make sure that everything works. So if I say Python 3 here, you can see it's actually running an even older version of Python. So what I'm going to do is check out our code and see if I can figure out whether it's going to have issues here. So if I go to GitHub Actions demo and I say code and I copy this, I can go through to Azure and do git clone. There we go. So able to clone this in my Azure environment, and then I'll just cd into there. And we see everything set up. So I would need to create a Python virtual environment here. And in order to do that, I could go ahead and type in Python 3-m venv and use that same technique, .github actions demo. There we go. And next step, I will source this, source GitHub Actions demo bin activate. All right, now if I type in make install, it will have a problem, I believe. There we go. So we can see, look, Python 3.5 has reached the end of its life. So basically, Azure here is being a little bit naughty and it's keeping around Python 3.5 here. And so let's see what kind of problems get introduced. So here we go, that there's no version for black, right? So we know that that's one problem that we're having. And so maybe what we'll need to do is actually remove that in order to get it working in this environment. So what I can do is click on this link here, which will show me the editor. And Azure has as well an editor. They're all these cloud companies have similar things. And I'll go to this project, which is called GitHub Actions Demo. And I will go to the requirements file, and I will just get rid of black, since we know that that won't work on our project. And then I'll also go to the Makefile, and I will just remove this or comment it out. That might be a better way to do it. I'll just comment this. And then I'll also go to the GitHub Actions build process under workflow. And then what I'll say is that I want to actually go through here and remove this formats step here for this project, and potentially even, I think it told me before what versions of Python it could run at. And if I go back here, let's see if we can figure this out, is if I go to the old builds, there was one where we were installing Python 3.7 and it broke, and it told us what versions were. Here we go. So it says Python 3.5.10 is available. So let's go ahead and change that. Let's change it to Python 3.5.10. So we'll say Python 3.5.10. And what we can say in here as well, Python application test with GitHub Actions for Azure. right? So we now have a build process for Azure that can verify that everything is working properly. And let's see if we can get this to work. So I'll change this and I'll say make install. Okay, and from here, this should get our environment working. And if I say make lint, the code should work. There we go. Make test should work. So we just needed to remove that one step, and then if I commit it, I can actually go through here and do this. Just say git add GitHub Actions workflow, and I'll add the make file, add requirements file. There we go. So fixing our project to work on Azure. And then let's double check. Let's double check that this works. And we'll go back to this. Now, I believe one of the things I wanted to do next is, now that we've got this working in Azure, is to, I believe you can have multiple parallel jobs with GitHub Actions. And so that might be a neat trick next, as long as this works, is to see if I can get two separate build processes testing separate versions of Python. And then what I could essentially get the best of both worlds here, which I think you can do this. I think you can have multiple GitHub Actions build steps. So I'm going to go ahead and try that if this works. So great, linting works, testing works. Okay, so I know that Azure appears to be working well. And so why don't I try that? Let's see if I can create a new, yeah, I think you can. You can just say a new one. And then I can put the old workflow inside. And so we'll call this one GCP. And then what I'll do is actually take my old code that was working previously successfully, which is under here, GitHub Actions demo, and have two parallel builds, which I think is pretty neat. So if I go to the history here, I can grab the last one, which was this one, and I could just look at the raw file here, which should be a view file, and just paste the old one in. So paste this in. And now we could actually test both at the same time. So the format I'm going to leave out temporarily, but I'll bring that back in a second. So we'll go through here and we'll say start commit, and we'll say creating second build. And now we can actually test both Azure and also test GitHub Actions with GCP. So here we go, and we say one job queued, creating second build. And so this one is testing Python 3.7.9. That looks like it works. And so what we could do here, that would be, so it looks like it works, but I believe it looks like it passed. But this would now run in parallel. This should be also the Python 3.5 one. Yeah, Python 3.5. So we could just clean this up a little bit and actually do some interesting parallel builds. So what I'm going to do is I'm going to pull this down so I can make it a little bit more explicit. And I'm going to go into my editor here and look at these workflows. So there should be 2 here, right? If I refresh, yeah, there should be GCP and main. So for GCP, I'm going to name this a new name. I'm going to say basically GCP Python 3.7, right? So I have an explicit build step for GCP, and then what I'm also going to do is I'm going to add in that format step again. So I'll go through here and I'll say run, just do this, copy this, paste this, there we go, it looks test. So we'll say format, and I'll need to change the structure of my project to support being able to test multiple things at the same time. And in order to do that, notice how it says make install. Why don't I say, instead of make install, I'll say make install GCP. And then I'll go back to my Makefile here and I'll add in a new install step that says install GCP. So we'll go through here and we'll add another step that says install GCP. And what this will do is I'll tell it to do requirements GCP. And then I'll add another file called requirements. So I'll just CP requirements to requirements GCP. So I can explicitly have a whole other branch that I test, and I can test multiple clouds at the same time. So to do this, this looks like that would work, right? Pip install GCP, install GCP. If I go back again to my GCP workflow, we can see that this says make install GCP, make format, and then inside my requirements GCP, I need to add in that Python black tool. There we go. So now I also want to change this main file here to that good. It says Azure. Maybe I even put this at the front so it's easier to read. Say Azure Python application test for GitHub Actions. That looks good. All right, so we've got GCP Python 3.7. We'll say Azure Python 3.5. All right, this looks like it's good to go. If I push this, git status, we can see there's some new files here that I'll need to push. So there's GitHub. We need to add that directory. We'll need to add this requirements file. And we'll also need to add the Makefile. And then I'll commit this, adding a new GCP-based build. All right. Now that I've got this new build here, if I go back again to GitHub Actions, you'll see that it triggers simultaneously a GCP build right here and an Azure build, which is pretty cool. And so if we're lucky, I might be able to do also AWS. But first, let's just double check that each work. So I'm going to go to GCP, double check that this new build works. And here we go. It's building. It's installing the dependencies. It's testing. So this one looks like, I'm sorry, this is Python 3.5. And then the other one would be this one, which is Python 3.7. So this one had a problem. There's something, no rule to make format. So that's easy to fix. We can fix this. In fact, so I'll fix this on the GCP cloud. So I'm going to go back to GCP here. And I'm going to do a git pull. And in fact, this is correct. There is no make format. I can just uncomment this out because there's no problem having lots of build steps. And then if I type in make format, there we go. We know that this works. So basically the install, we can say make install. That works. We can do make lint. That works. We can do make test. That works. And we can do make format. So now we've got really we're doing pretty well here in that we have two totally different versions of our build, and they're all being automatically tested with GitHub Actions. So let's go ahead and add this, and then do test hello, and adding GCP build. Perfect. So let's go ahead and verify it with GitHub Actions. And again, we've got GCP, which failed before. And this, I believe, should now work. So what's great about this is that we had that earlier problem with the AWS cloud platform, and what I can do is actually go through and fix it by so here we go, format works. So we have two totally separate build processes that are unique to the cloud platforms, but remember I still had that problem with AWS. So why don't we fix that by kind of being brave here and adding one more actions that's totally different. So I'm going to go to actions again, and I'm going to say I want yet a third workflow, and I'm going to set it up myself, and I'm just going to paste everything in here. So I'm going to just delete this. Whoa, don't want that. I'm going to delete this, and then I'm going to paste in this thing and just tweak it a little bit for my AWS environment. So paste this in, and I'll say this would be AWS, and I'll double check what version of AWS here I had, or Python 3.6.12. So let's see if we can verify whether this would work. And I will say, and I think we could look at this as well, and we see what versions are supported. If you remember from earlier, I was able to see what versions of Python were supported. There was it Python 3.7.3 or all workflows? There was one from earlier that told me which versions of Python. So it supports Python 3.6.12. So sure, let's try that. Let's see if we can get this isolated here. So I'll say Python 3.6.12, and again I'll put this right next to it. Python 3.6.12, Python 3.6.12. Perfect. This is the one I want to test. And then I will say Python 3.6.12, and then again Python 3.6.12. But what I'm going to do this time is I'm going to be much more conservative. I'm just going to rip all this out and only do a very simple installation step. And I'll say as well, make install AWS. And then when I commit this, I can actually be much more conservative about how this works. And I'll say AWS, we'll just call this AWS. Commit this. Okay. So we got AWS here. And if I go back to my environment and I do get pull, it should be able to pull in those changes to GitHub Actions. So if I go into here, I can look at this and see, okay, close all. I can go here and say, okay, look, this looks like it's potentially what I want, Python 3.6. And then what I would need to do is make this install step called install AWS. So go to my Makefile and make a new install step called install AWS. And here we go, install AWS. And we'll say requirements.aws. And let's also make a new requirements file here. So touch requirements.aws. requirements AWS. And then inside of here we know that there are all kinds of things were problems before. So maybe we'll just test, does anything work? Maybe we'll try PyTest. Does PyTest even install? And we also can maybe make a new environment in this new environment. And so I can say, look at the history, and just I'm going to remove this directory if it existed. So I'll type in, just kind of start from scratch, create a new Python virtual environment and source it. And then source it. There we go. Okay, so I can now do the build step, which would be here, which is only go to this requirements.aws file and install just those packages. So we'll say make install AWS. Does that even work? So basically nothing works on this particular environment because there's some kind of setup tools issue. And so we at least have isolated that there's, it looks like there's some kind of a problem. So what are my options now to fix this? Well, what I would be curious about actually is, let me push these changes and see if GitHub Actions, when it uses Python 3.6, if it has issues with this. So let's actually do this. We'll say git status, and let's see if we can keep digging into this problem, because we know that it's for sure we've isolated it to this version of Python on this AWS environment. But can we fix this by getting out of this environment? So we'll go through here and we'll say git push. And if we go back to GitHub Actions, we should be able to see the third build now. We should see 3 builds, AWS, GCP. And does this have a problem? Well, we know that there's something going on for sure. There we go. Oh, no rule to install make install AWS, but it should do it again because I think I pushed new changes. Let's double check though. So this one says install dependencies, no rule called make install AWS. Are we sure about that? Let's see here. Make install. I think there should be a rule. Oh, I see. It's misnamed. So if I go back here, is it misnamed? No, it looks like it's, or did I not save it? There we go. I didn't push these. So that's the problem. There we go. So let's see if this can fix this problem. If not, I believe I know another fix, adding changes from AWS. All right, we go back here, we look at these actions. We know that 3.6 here. Will this work? Now, there is one difference in this environment, is this is Ubuntu, and the AWS environment is running essentially Red Hat Linux. So that could be a factor, but let's see if this blows up. So that is appearing to work. So there could be just something weird going on with the Cloud9 environment. So that is, it's actually it's definitely useful information. So, what I'm going to do is I'm just going to get out of this environment for a second, and I'm going to open up another Cloud9 environment. I'm going to go here, and I'm going to create a new one to just see if I can figure this out. We'll call this Cloud9 2, and we'll call this second environment. And this is a new environment to build out testing for Python. Okay, let's try this. Now what I'm going to do here is I'm going to leave this the same, But notice how there's Amazon Linux, and then there's Amazon Linux 2. So what I'm going to do is I'm going to select Amazon Linux 2, which I believe has a newer version of Python. And so let's go ahead and see if that might fix our problem. Which again has really been isolated and beat to death because we know it works on Azure, we know it works on GCP, we know Amazon Linux, the first version, there could be an issue. So Amazon Linux 2, hopefully this is actually a much different experience. I'm pretty confident that there will be a substantial difference. In fact, we can create a fourth build in GitHub Actions, and this fourth build will actually be something that we can have a custom setup for. Okay, this looks like it works. Now let's kick the tires here a little bit and see the difference in terms of what Python is installed. That might be one of the first things that I would do, is once the shell wakes up, is it hopefully not running Python 3.6, which appears to be a real problem. Okay, wake up, wake up. Maybe I even open up a new shell to wake it up. Oh, there we go. So this thing's woken up. If I type in Python 3, which version does it have installed? Okay, it's got a very different version of Python. So Python 3.7.9, and I believe we can look. Oh, it does run Python 3.7.9. Excellent. So we can actually go and create yet another one, and we'll call this one Python 3.7.9. So I guess first I could copy this code here. So go here, copy AWS, and let's just use this as the template. Make a Python 3.7.9 AWS, and we'll go to Actions, make a new workflow, set it up, and we'll do this. But we'll say AWS Python 3.7.9, and it's Ubuntu, which is, we don't necessarily need to change it. We could, but this is probably good enough for testing, and then do the same thing, put Python 3.7.9. All right, so we got this, and what I'm going to do is I'm going to call this one make install Amazon Linux 2. Right, that looks pretty good, and we'll go ahead and save that. And then what I'm also going to need to do is rename this thing. So we'll call this AWS Linux 2. And we'll commit this. There we go. Remember that because it's a new environment, I'm going to have to give it the SSH keys. So I'm going to go ahead and do that. Go Amazon Linux 2. And then I'm going to go to this cloud environment. This is our second environment. We'll put it right here. And I'll go ahead and do SSH keys. Cat this out. So I will go to this file here and print this out, copy it, and then go to my SSH key section, add it in. There we go. So now if I do a git pull of that repo, which is here, I can get to work. So there we go. We got this working. Git clone. I don't want to do a git pull. I want to do a git clone. Git clone. Okay. Clone this thing. This looks good. And now I'm going to do the Python setup stuff that didn't work before, which hopefully will work, is python 3-m venv. Same thing, dot GitHub Actions demo. And this creates the environment. And then I'll just source it. So source tilde dot GitHub Actions demo bin activate. And now here's the $1 million question is, will everything work to start with? Will anything work? And so if you remember, we changed things a little bit because there's all these different make steps. And so in this particular setup, I'm going to add one more install. I'm going to say install Amazon Linux. And then I'm also going to paste this down here. And I'm going to call this Amazon Linux. So we've got a fourth build step here. So there we go, Amazon Linux. That looks good. And then I'll also need to make that file. So I'll say touch Amazon Linux.txt. There you go. So now that I've got this set up, I can just step by step decide what I want to put in here and be cautious at first. And I believe, in fact, that, let's just refresh this. Not sure why. Oh, I know why. Because I need to move Amazon Linux into this checkout directory. There we go. And now I need to change it to the directory. Okay, so we see this Amazon Linux.txt. So inside of here, I'll just be cautious and I'll put in just PyTest. And let's now do a make install Amazon Linux. Make install. Let's do make, and we'll do this make step, which is this install Amazon Linux. Much different setup now. Now everything works. So it looks like we have isolated that version of Amazon Linux maybe has just got a problem and you shouldn't use it, which is pretty cool because that's an old version of Python 3. And so what I would do then is go to my full-fledged environment and just start recreating this. So now that I've got it, I can basically just, we know PyTest, all this stuff works. That looks good. And what I can do is actually essentially get this whole thing cooking now by doing a new install. So just say do a make, do the same thing, make install again, and then update. Everything looks like it's totally fine. Actually, I didn't save it, so let's do it again. Let's try all these other packages. They look like they have no problem. Everything works great. So this really is a success story for why you would use GitHub Actions to debug a problem. The next step would be, let's get the rest of the build process working. So if I do make lint, that works. If I do make test, that works. And if I do make format, that works. So basically I can actually go back to my GitHub Actions config here and tell it to do more stuff. So I can basically copy all the stuff that the GCP build goes here. And let's try this. And let's just paste the rest of this. So we don't need their build process. We want our build process. So we've got an install, we've got a lint, we've got a test, and we've got a format. So we have a custom install for this environment as well. And let's go ahead and do a get status and add those changes. workflows. There we go. Add this. Git status. Let's see what else. Oh yeah, git add Makefile. Git add Amazon Linux. There we go. And pushing Amazon Linux build, Amazon X2 build. There we go. And now it's going to ask me to do the same thing, set up my original git config. So I'll do that real quick. Put in this. Push this. There we go. Write it out. And then push it. There we go. Perfect. So we go back to GitHub Actions, and we've got 4 builds now running, which is pretty cool. Actually, I've never had that. I've never had more than one. I was just guessing it could do this, but we've got AWS, mostly AWS native version 3.7.9, AWS 3.6.2, GCP, Azure. Now, what we could do, let's just first make sure this works. Well, it doesn't, so let's figure out what I broke. Let's go through here. We'll build this, and it says no rule. So I must have just did a typo. Let's fix that. So it says make install Amazon Linux 2. We must not have that inside of here. We must call it, oh yeah, I just named it a different name. So we'll fix that. And where's this? We'll make it that. There we go, Amazon Linux. And then up here, I can say, in fact, AWS Amazon Linux 2. And git status. We added this file. Let's push it and double check that it works. So we've got a lot of really powerful things hooked up here, adding Amazon Linux 2. The other step that could be basically the icing on the cake would be to also test this on maybe a Yum version. I'm sorry, a Red Hat Linux version / CentOS, which I don't know if I'm sure they would have a build for that, or container for that. But we can. That might be the final thing to attempt and see if we can get that working. So we know set up Python 3.7.9. Perfect.